Very pleased to introduce our speakers. We have Colleen Connors and David Maberry. Colleen has over 16 years of professional experience spanning technology and finance. She is currently the Chief Operating Officer for Verif-y. And David Maberry has over 25 years of experience in leading the application of emerging technologies while streamlining governance requirements and creating sustainable organizational change. David is currently the VP of Business Development and Risk with Verif-y. So welcome to both of you, and I will kick things over to you.
Cool. Thanks so much, Emily. So I'm going to start, and I'm going to let Colleen drive because I've been known to mishit things on Zoom meetings, and that causes much confusion and consternation. So thanks so much for the background. What I wanted to talk about first, and we didn't know really what level of knowledge the audience would have around blockchain and its use. And really my background with blockchain was primarily around the cryptocurrency environment and building out how do you translate new technology to meet current regulatory frameworks around financial services. So how do you do reporting on Know Your Customer? How do you provide audit? How do you assess risk? That's really where I worked. And I was lucky enough to work on two of the largest rollouts of crypto-based platforms. So I got to see quite a bit of proper use of blockchain technology and really successful use of blockchain technology, and quite a few examples where people, to use the Portlandia example, would just try to put blockchain on it, and that would solve, all of their governance and security and compliance issues. So that tends not to work very well. So we'll start. If you want to, Colleen, you want to flip up slide number 1. I can't see it. Ta-da! There we go. There's our fancy PowerPoint. So if we go to the second slide, I'll just give everybody a brief, high-level, non-technical primer on the history of blockchain. So if you look back to really what sprung this thing forward, it was a guy named Satoshi Nakamoto, who may or may not be a real person. There's still a lot of debate around that. And his paper that he published in, I think, 2008 called Bitcoin, a peer-to-peer electronic cash system. What he intended to do was to create a solution that would allow people to exchange money without having to go through a third party. And that solution would provide full autonomy to the users. It would provide full visibility to the transaction, and it would not need a third party to validate it, which is the case in a lot of our current financial systems with, as I'm sure well, bank fees and charges that are applied to you financially just for trying to use your money in your bank account. So it was a very forward-thinking paper. If you haven't read it and you're interested in it, it's one of the few technical pieces I've read that is fairly short. It's about 9 pages to the point and explains the interaction between these two areas, which are digital ledger technology. So I've got a ledger and I've spread that ledger out across multiple areas or nodes, as they're called in blockchain world, and I'm encrypting that, meaning that I'm hashing it or mathematically making it really, really difficult for somebody to solve for. So in the case of blockchain, especially because of the level of encryption applied, which is, you typically hear encryption described in terms of 128K, 256K, 512K. 256K is, which SHA, I guess is the correct term now, is the highest level of encryption we can effectively apply today without draining the power supply, which gets into how does the blockchain work? So it's encrypted, and there's 2 types. There's public or permissionless, which in the case of Bitcoin is a public permissionless network. It's set up, There were 22,000 Bitcoins created. They were distributed, and it runs in basically in an eternal fashion. It needs to be updated occasionally for changes in technology, it needs to be optimized for power consumption. But basically that blockchain exists, and you can see every transaction that has been applied to that blockchain in real time and historically. So public is really the idea that got this whole thing going. And then you have the more evolved usage, which is our permissioned or private blockchains. And in those cases, that would be like where an enterprise applies it, like an Amazon Web Services has a type of permissioned blockchain network. Ripple is another one that people are somewhat familiar with. Those are blockchain networks that I can set up and I can let people in and basically allow access to that network on a permissioned basis. So those are the more common applications. If we go to the next slide. Thank you, Colleen. We can talk a little bit about where it can be applied. And this is where I wanted to spend a bit of time just in my sort of history in the world of consulting and wandering around and seeing a lot of different companies and how they used emerging technologies. So the most obvious application for this type of technology is financial services. It's rules-based. So things like a transaction, did the transaction occur? Yes, no. Is the transaction completed? Yes, no, lends itself very well to blockchain type applications, because in addition to recording the application, it also gives me the ability to audit the application. So I can go in, and if there is something that has fouled, let's say the works a little bit, I will be able to see that and be able to backtrack and apply a methodology to audit it, which is different if I go on my audit hat than the way we currently audit these types of transactions. Currently, you're pulling a sample of 30 and you're applying that sample against a population of hundreds of thousands, if not millions of transactions. So our current methodology for monitoring these services really is broken into the relation and speed of the service and the transactions that are being provided. So blockchain's a really logical application for banking, especially, but also for things like real estate and title transfers. And healthcare is another area that, when you think about it, and I'm going to go into a little bit more detail on this in a second, healthcare really gets to that core of identity and being able to manage your own records, which in the United States is difficult, I'll say, politically correctly, because of the wide variety of coverages, the wide variety of coverage options. The different laws that have been applied in healthcare make it sometimes wonky to try to apply a single standard across all the private payers. And then finally, government, which also bleeds back a little bit into healthcare, but government, I think, is really a cool example of where blockchain has been applied effectively, is the country of Estonia, which I have to say I was not, a big Estonia person. Dilbert was probably my primary exposure to that, if anybody remembers Dilbert. But if you go to the Estonian government website right now, they've turned almost their entire government processes from identity to taxes to property, anything that you need to interact with the Estonian government around is run on a form of blockchain technology. And by doing that, they have actually cut 2% out of their total spend on GDP just for government services. It's a super, super slick way to think about the possibilities, and really where Verif-y, our company, plays is in that core identity space. But Estonia has really taken it to the next level and has applied a degree of advancement that I haven't seen any other country attempt to apply. So what you get out of all this is you get something that's immutable. So there's always a record There's always going to be a ledger with a transaction on it showing when the transaction was made, who was approved, and it's going to be done in a really efficient way that's also very transparent. And those three elements are what really make the magic happen. You don't need a human to intervene if you're setting this up correctly, which gets to the successes and challenges standpoint. Where I saw a lot of organizations struggle with the application of blockchain was around, as I said earlier, you can't just walk into an existing process and put a blockchain on it and the process is magically going to work and be better. It doesn't work that way. With newer technologies like blockchain, with AI, even machine learning to a certain degree, sometimes it's best to start with what the technology can do and maximize that, as opposed to trying to fit an old process or an outdated way of looking at risk, audit, whatever your accounting functions, and then trying to force that into a blockchain. That can be very, very difficult and time consuming, and ultimately not bear the fruit you're expecting it to bear. Something as simple as interbank transfers, changing electronic fund transfers to being more of a blockchain basis, can be difficult if you're not approaching it from the standpoint of where's the technology best going to play. And I think that's a really important thing to keep in mind, that it's not a panacea. It doesn't solve the world's problems, but if you're willing to think outside the box and really think about it as a rules-based system that is not a lot of gray, it's very efficient in what it does, it's completely transparent in what it does, and once it's done, it's there. You're not gonna, you have a very difficult time moving it. So those are the type of things that when you're looking at the application of blockchain, I think you can really take into account and majorly change how organizations that are heavily reliant on processes that lend themselves to automation can be improved. And then those workers, people doing those type of jobs, can transition into being more forward thinking, being more or less widget oriented and more outcome oriented and more customer focused oriented. So I wanted to walk y'all through a quick example that we have of Verif-y, and I'll let Colleen really get into the meat of what we do when she goes through her slide on why we see identity as being a core to the application of a blockchain type environment. And the reason I say that is because of those transactional elements and the fact that you can validate the individual as part of that transaction. Sorry, Colleen. Okay, now I'll go. So what we have is an example of what the Verif-y digital wallet would look like. And we're going to talk timely about COVID testing, of all things. Shocker. But it's important because I don't know if as consumers, you've noticed the proliferation of COVID checking apps and COVID QR codes. All of these things are great, but they're also very easily spoofed. So what Verif-y does is goes to the source of the test and verifies that this is in fact a LabCorp COVID-19 test, and it has been credentialed and accepted by LabCorp, and there is evidence of that accepted in the wallet. So you've cut out a middle process and gone directly to the source, and then that source goes back to the storage wallet, in this case for Jane Smith. So in our next slide, what we show is then how Jane, who suspiciously looks a lot like Paige, but we'll still call her Jane, could then use the QR code to demonstrate her vaccination at a store like a Rite Aid, rather than her having to carry around a separate card, which, strangely enough, the CDC vaccination cards still look like the CDC vaccination cards from the late 50s. where somebody handwrites on it that you've had a vaccine, and then you carry that card around with you along with your social security card and your driver's license and a lot of other cards. In this case, I don't need to carry the card, and the card frankly can be spoofed fairly easily. I just go to my wallet and I can demonstrate on my wallet via a QR code that again links back to the source. Here's my health information, and here's how this vaccination and when this vaccination was taken. Then if we go to the next slide, this is what would happen when we would scan the QR code. So if you're, again, let's say you're flying somewhere in China, this has been taken to a fairly extreme level where they even use QR codes for access to things like public transportation. And the efficiencies, though, that you can gain from that if you're moving back into offices or you're trying to host large events is a verified QR code gives you a certain sense of confirmation that goes beyond just a card and a signature. You've gone to the source, you've validated it at the source, and that can be demonstrated through a reader to anybody that has need to see that information. The information, though, isn't necessarily stored with that person. Jane will keep the information on her wallet because she's just sharing it. She's not giving it for permanent storage. So an example here might be when you go to check into an office building and you need to get access to the elevators, they take your driver's license, they scan it into a machine that looks like it came from a state fair, and then you're magically granted access. Not there's anything wrong with state fairs, but the machine is not the most technical thing on the planet. So once that information's scanned there, and this is one of my great questions in life, there's a lot of front desk kiosks across this country and frankly across the world that have copies of your driver's license. What happens to those? We really don't know. That's kind of this netherworld that doesn't have a lot of oversight. In this case, all they do is scan the information and they have a record that the information was scanned. They don't keep any pages of other information. Sorry, James, other information because they don't need to. She's permissioned this. They see this. It validates the check. They can move on. And that's really key. And when you start thinking about the application of the technology, I, as a user, can give you company, institution, official, I can give you access to my identity only for the purpose you need it for. And then I can take that identity back. There is a record that the event has occurred. It's immutable. It's in the system. If you're audited, you have proof, as opposed to you having to store all of this information in an HR department, behind a security desk, in file cabinets located in a storage shop somewhere. It starts to narrow down the proliferation of information that we consider private by allowing access for specific use only. And so after that, you have the complete user profile. And that shows how everything is complete. This could be shared again through that QR code. And again, what it gives you is the ability to share needed information at the time of need and not create a burden or a risk to your personal information that it's being shared outside or it's lost by a organization that doesn't necessarily consider your privacy core to their information. And with that, I think it's time to turn it over to Colleen and talk about how Verif-y leverages.
Thanks, David. Well, the first thing I want to discuss is just how we define identity. I think this is paramount in everything that we're doing today. It's obviously a really hot topic, and it's something that we all should care about. I think sometimes we don't even realize we need to care about it until there's a problem. So, you know, we define historically identity many ways. race, nationality, age. There's all these little factors that go in to define and say who we are. Now, we think that they should not just be maybe those traditional ones that you get at birth. So your name, that nationality, maybe a numerical identity like a social security number, and the date of your birth. Because how unique are those pieces that we call part of our identity? So if you were to Google my name for laughs, you would actually come up with a whole bunch of people that aren't me. We all have the same name, but we're from different countries. Some are from Canada, some are from the US. We live all over the place. But just on LinkedIn, there's over 50 profiles with my name, first and last name identical, with identical spelling, not even ERS. So we believe at Verif-y that identity should be defined in many more ways than just those traditional ways, such as your educational background, your employment background, any certificates or licenses or other things that are truly unique to who you are and the journey that you have walked through life. So one of the ways that we do that is by making sure that we can take care of that education record in this example. So we provide a tool that allows you to upload and submit your educational details to the registrar at your university, then allowing you to hold a verified educational credential of the institution and where you attended. And you know that that is verifiable by the registrar based on the information that we provide. And then we store that on the blockchain. So here you can see in this little example, we take all the pieces that are necessary that the registrar would need. It then goes to a pending status. Once the registrar verifies it, it changes in color to green. And then you can click on it and see the blockchain hash and blockchain ID that is tied to that exact record. Now I'm going to walk you through some more of the details of that in a second. So as it moves through those different stages, so it starts as a pending record, then it goes to that verified, rejected, even other statuses that could happen in its progression and journey. We use the blockchain in order to track, store, and secure that user's record, and thus their digital identity and the journey in which we're taking to get there. So each record, sorry, I just have to click in order to make everything work too. Each record, each time a record is created, it also creates a unique identifier on our platform and on the blockchain. This is called a blockchain ID or a transaction ID. So on the block, we have a public permissioned blockchain network on the Ethereum network is what we've built on. And all of those roll up into what we call a block hash. When you actually click on that unique record, you get that alphanumerical strip that is tied to that block hash because it is a blockchain transaction ID. Now, one of the things you don't often get to see, which is why I think it's very important to see this, is actually what it looks like in real life in an Explorer view. So if you were to click on to that alphanumerical string and actually get into the weeds, this is what it looks like. And there's a lot of components that are happening kind of under the hood. So here you can see, I just kind of highlighted in red that same alphanumerical string and where you can see it and how it maps through the Explorer onto the blockchain to trace that journey. So here you can see at the bottom, you see the hash number, that transaction ID. Those are the same things. Those are interchangeable terms. And then you can see even more granularity of that on the other slide, graphic on the right, which is actually what numerical block that transaction ID is tied to. So all of these pieces are how we track that journey within the blockchain that we're using. So all of those pieces we believe are really important to map that someone is uniquely them when we're talking about identity. Now, blockchain technology does a whole bunch of stuff. To me, it really does two distinct things. It helps us store data and manage data. So whether we're using transactions and ledgers or storage or something tied together, both of those pieces are things that we're utilizing the blockchain technology at Verif-y for. And hopefully one day We want lots of people to have a much better, more trusted identity by using all of these pieces. One of the things I wanted to just touch on a little bit more is this concept of centralized to decentralized. This GIF is a little fast, so sorry if that's already making your head spin a little bit. So if we think about storage today, so if you think about Dropbox or Google Drive, or even your AWS storage that you're using today for work, that is a centralized storage facility. Everything that you're storing is in one place. It is all together. It is at that starting Rubik's Cube, and it's all tied. So if it gets hacked, if something breaks into that, it's able to access everything at once. So that is not, in our opinion, the most secure way to store data, because there are other options. And blockchain technology provides that other option. So here I'm just using a Rubik's Cube because I think it's a good visual. Decentralized means that it's in many different places. So it is not a little piece. All of those blockchain hashes and blockchain IDs, transaction IDs, are in different locations. They are not stored on one computer. They are spread through the cloud all over the world, or on servers, depending on how it works. But they're spread out. So from a security standpoint, they are exponentially more secure in protecting your data. And where we feel that that is the most important is with your identity data, those pieces that truly make who you are you, and that people are trying to hack, right? We've had numerous data breaches happen all over the world in the last several years, and it's only getting more prevalent. I'm going to switch over to David for our last few slides to describe this in more detail, but obviously storage is paramount to our view of how blockchain technology should be utilized.
As I mentioned before, thanks, Colleen, the idea of every record is immutable, and they contribute to this immutable ledger, but that ledger really is owned by the individual. It's owned by the person. They permission and depermission access to that and have 100% control of that record, which is kind of the cool thing. And I think the really revolutionary thing about this is if you think about the last, call it 20 years, our data as individuals has been used, abused, stripped, reformatted hundreds, if not thousands of times. Every one of us has a database there. If you're online, you've got a database. You probably have hundreds of them, if not thousands of databases that all manage little parts of what make you up as a person and let companies target their information to you. That's important for the company, but it doesn't necessarily provide the greatest stewardship for that data. And that data, in many ways, is the most important thing you own. Because if you lose your identity, those of you who've had your identity stolen can attest, suddenly the burden of reproving your identity is put back in the end user's hand. It's not the fault of the company that lost it. It's your fault because you were there. So from that standpoint, and the growing concern, I think there's an identity now stolen every 3 seconds in the United States, not even globally. When you really start thinking about that, and then the efforts that a lot of companies have gone through over the last 10 or 15 years around creating data lakes and data pools, where they conveniently put all the data in one place. So if you are able to access it, it's much easier for somebody to take that and distribute it and sell blocks of it. The new in vogue trend, and it's what's been happening a lot in the United States with access to the government funds, is to use something called a synthetic identity, where somebody takes Colleen's name, they take another Colleen's picture, they take another Colleen's address. If they're really lucky, they've got a social security number from a different person who's also a Colleen and a birthday, and they're able to spin up an identity, and it looks and feels real to the organization processing that transaction, because the blocks that are used to check that are mired in a system that really didn't start developing until the late 80s, early 90s. and hasn't really evolved significantly since. We view this as a really revolutionary way to think about privacy and the components that relate to individuals' information, but also to companies that want to make sure that the people they're dealing with are the people who they actually think they're dealing with, and not 50 Colleen Connors with varying addresses and pictures. So in closing, what we wanted to talk about, and Colleen and I will do a little dueling banjos on this, is a concept that we call the privacy layer. And what we mean by the privacy layer is it's a wedge, it's a gap between the individual and the company that they're transacting with. And it allows that information to be stored in a decentralized way that's not a single point of control, but it's also in a way that can be shared as needed with companies that you interact with, whether that's for hiring, whether that's for something like a background check, which right now in healthcare can be kind of a nightmare if you're trying to staff a nurse, for instance, and you're competing in a market with 5 community hospitals. Those 5 community hospitals may all have different background check processes. If that nurse had their credentials verified, had a background check, and was able to share that with those hospitals, you cut the hiring phase in half. We go from days to what is currently weeks in some cases. I know for some of the major banks, just getting onboarded, going through the onboarding process, it's 6 weeks, best case, 4 weeks if you're lucky, because of the decentralization of how that process is managed in the hiring process. So we see privacy layer as being a way to give companies quality information about the people they're dealing with, but also to give the individual the rights and protections that they should have around their most important asset, which is their identity. And that's what blockchain does really, really, really well. It provides the transactional mechanism to do that. And Colleen, you want to add anything?
No, I just think I want to highlight also that chain of custody. I think that chain of custody is really important in this case, and that blockchain does a wonderful job of knowing that chain of custody throughout the process. And yeah, so I think that's the only thing I would want to add. And obviously this privacy layer is something that we're really excited about at Verif-y, just enabling clients to store data in a much more secure, decentralized way, especially their personal identifiable information, which is at the heart of who we are. And it's something that I think we all need to be more cognizant about. And as this is why CCPA is existing, GDPR is existing, and companies like Facebook are being asked by Congress to come and talk. And so, our privacy is at the forefront of, legislation today, and we think it should be at the forefront of all individuals' minds as well. And blockchain is a wonderful way to help us protect our data, and the way that we look at it is really giving that ownership back to the hands of the users and out of the hands of corporate America or global corporations. So I think that's concluding. Anything else? More, David? Did I miss? I have so much more I could say, of course, always.
Yeah, no, we could babble for hours.
Yeah, so we're happy to talk now. Should I stop sharing?
I would invite folks, if you have any questions, to feel free to toss those in the chat. I know I have a few. I mean, first, this was wonderful. I was chatting with David earlier in the session, saying that your monthly theme is cryptocurrency. And one of the things I learned is that I know nothing about cryptocurrency. So I do appreciate it being broken down a bit in the beginning. And I think one of my main questions is what I think is so interesting is I've never thought about in terms of personal identity. I feel like it's typically talked about in terms of, financial identity, and using it in that way. And I'm just curious about where you see the next applications for blockchain and, in the future, and how you see that expanding.
I'll take it first, David, and then I'll throw it over if that's okay.
Cool.
So blockchain technology really started to gain momentum globally, I'm going to say now 5 years ago. And 2018 kind of hit this other sweet spot of momentum where every company, every big name, IBM through Goldman, was making sure that they had departments that had the word blockchain in them. But you had a lot of innovation happening in the startup world. And that was everything from artwork to music to real estate. So everyone was trying to figure out, how do I use ledger technology? And a lot had to do with payments. So if I'm a musician and I want to get paid, but let's say I want to take out the middleman, I want to take the agent out of the equation and I want to get paid directly. So think almost like Venmo. How can I use blockchain technology to enable that? And people were really starting to find solutions. Now they had to have a coin and there was a lot more involved. And so there were some barriers to entry there. I think to David's point in the beginning, everyone thought that this was going to be like this instant problem solver, taking the middleman, let's say that agent out of the equation, so I make a little bit more money, but it was a lot more complicated than that. So I think that these are still applications that are going to be utilized. I just think we needed to do a little bit more on the tech side to get a little bit deeper in before we unleashed it on absolutely every possible, way that we could use a ledger. So what I'm seeing right now is, obviously, as David said, is banking, right? I was on a conference yesterday where banking and identity and blockchain were all highlights of the conference. And so I do think that banking is the primary #1 place to start this. Supply chain management is another huge area. I know a startup in Scotland, actually, she's actually a Philly native, but moved her company over to Scotland because of financing. But her whole company is utilizing blockchain technology in order to do supply chain management. So let's say managing and knowing where beds are in a hospital. So a bed moved from room 108 to room 216. How do I track that movement using blockchain technology? And she was utilizing that technology to do that. Airline industry for supply chain management as well. So I think there are numerous, it feels almost limitless in where it already is, to be honest. But we're still working out the kinks, I think, in many regards. So we're not there yet. And I'll say also there's quite a few departments and companies and big names that have kind of stopped because they put a lot of money into this, 2018 through, I'll say even last year, and then weren't seeing the results as fast as they wanted to. And so they kind of just canceled projects. But I'll say I almost feel like this year and then the last 6 months, I'm seeing a bit more of a resurgence of, desire to make this work. And I will say crypto valuation isn't hurting that spike in interest either. So, all right, I'll punt over to you now, David.
I'd say that's it. You can tell the investment in the blockchain market by the value of cryptocurrency. I mean, that really is the driver. And so now that Bitcoin's up close to 60K, there's a lot of investment in the technology. And I think one of the challenges, which is one of the advantages, is it is kind of a limitless opportunity. You can do a lot of things with blockchain. And I'll give you an example of one in financial services. So when you sign up for a bank account or you want to do any kind of transaction through a bank, they have a process called Know Your Customer. They have to validate who you are. A lot of the smaller banks, community banks, still have that transaction governed very much by showing up at the bank. They make a copy of your driver's license, they run some checks. It's all very paper-based. They keep a file. When the regulator shows up and wants to see their KYC process, they pick a sample out of that file. But it's paper, it's disparate information. All of that can be done via blockchain. A member of our advisory board even said, and he's with a pretty large regional bank, that he sees that really as a difference maker. The banks that can't really evolve and are still kind of stuck in that paper mode. One, it's slow, so you're kind of dragging from a standpoint of just getting the customer into your bank, but also there's a significant amount of risk and loss of confidence, especially in COVID land, when somebody wants you to make a copy of your driver's license and put it in an envelope and send it to them so that they have a record of your driver's license or your passport. So part of the opportunity is really industry saying, for some of these areas, maybe we need to take a step back and really think about what are we trying to do here? What parts of the process are the same across industries? What parts of the process are absolutely required from a regulatory standpoint? We're not worried about the process, which in some cases still is somebody printing an Excel spreadsheet and then entering that into an Oracle system that may or may not feed another system. It's sort of, really attacking the existing infrastructure and questioning, well, why are we doing things the same way? Let's start over, rebuild, and there's a lot of potential advantages. Again, Estonia to me is mind blowing. They even offer an e-passport. You can open a business in Estonia with it. You get your e-passport, you do your biometrics, you're an Estonian entrepreneur in, I don't know, 72 hours, 48 hours, kind of depends on how quickly you can get to an Estonian embassy. But I mean, it's transformative when, especially in the United States, when you're having to put a copy of your driver's license and your voter registration to prove that you are the person you say you are when you're remote voting. I mean, just really antiquated, processes that we need to really challenge. Why do we continue to do these things the same way? There are other options. Sorry, I got on a soapbox. I'll get on.
There is a question in the chat from Bob Miller asking, if there is a mistake in the blockchain record, how does that get fixed?
I like to describe the blockchain in very old me terms, which is like old Christmas lights. So the way the old Christmas lights with the big bulbs worked, that would occasionally break back in the day when things broke. Once one of those lights went out, it just stopped working, and you'd have to go down the chain and test each light and figure out what was where. That's kind of what a blockchain does. When a blockchain is broken, when that trust that is broken, the blockchain doesn't work. It stops. It has a woe. Fixing that can be sometimes challenging and problematic, which is one of the problems with I don't know how many cryptocurrencies there are now, 2,000, 3,000, pick a number. There's a lot of them. But if you read the fine print on some of those, there's a big difference between a public blockchain and a permission blockchain, and how those transactions occur. The errors should be public. Sometimes they're not. Sometimes you see things like with Ethereum where the chain forks, but the other part of the chain's still running, so people lose money. There's a bit of a Ponzi aspect to parts of it, but at the end of the day, if you just stick with Christmas lights, that tends to if it breaks, it doesn't work. The chain is broken. And that's the way I think of it in my, rather simple colloquialism driven vernacular.
I see David Beckett, if you'd like to unmute and ask your question.
Hi, everybody. A few years ago, I had the quest to sort of look and see where I could identify the very first virtual transaction. And it ended up being a bank in Philadelphia, the precursor to Brown Brothers and Harriman, when they introduced the letter of credit. And for me, it has an awful lot of similarity to what if I understand you all correctly, hear you describing. So back in the 1800s, you had a manufacturer that would produce goods, send the goods to England, receive payment, and come back with all that money. Well, you had pirates waiting, and they could see and anticipate and then steal the money. And so when Alex Brown and Sons introduced the letter of credit, there was a higher level function that got introduced, which was that the products needed to treat everybody the same. So it was a fixed cost for everybody, and there was a standard quality of goods. That way it made it possible for goods to be shipped to multiple locations, and instead of cash being handled, in that transaction, it all was handled on ledgers. What I don't hear is what's the larger function that blockchain is introducing, that it's serving.
You want to go, Colleen, or I can?
Yeah, I'll start, and then I
All
think
right.
I can throw it over to you. So I think one of the biggest things, which I kind of spoke to a little bit already, is the centralized to decentralized. So rather than let's take your boat example of with pirates. So rather than all the shipment being on one boat, you would have parts of all the shipments on 20 different boats. And so if the pirates came and got a boat, they would get 1/20th of the whole, right? So if they were able to get something, they can't get all of it. So that's one of the biggest advantages that you're seeing immediately with blockchain is the centralized to decentralized nature. It's not one boat and then it's all sunk and you've lost all of the value of your goods or the cash. It is broken up into parts and stored all over the world and on the cloud, and therefore being able to get it and replicate it. So obviously transactions are data. Data is the biggest thing here. You're getting pieces of data. So your ability to put them back together, if you don't understand how they were put together in the first place, you can't do it. And so this is that security element is one of the biggest things that's coming and being changed from the way that we currently do things to what blockchain is bringing to the table. It's a new type, a new level of security. So that's the first thing that I think about that changes the equation of what we do today with blockchain technology to how we even did things 20 years ago with just storing data. And so that's the biggest thing for me, David. There's more, but Maberry, do you want to say anything else? I could say one or two more things.
Yeah, I was just going to add to that, David, that idea, that letter of credit, you still had to carry it around with you. It was still, maybe it's the possibility that letter of credit is faked. But if that's the only way that you're able to validate is through that letter, blockchain creates a methodology that can at least validate the letter of credit from its origin, its approval, how long it's good for, those various components that.
You're missing my point, David.
Okay.
What's the larger function?
Decentralization.
I understand that each of those things can be done.
Right.
But unless there's a larger function, there's not a transformation. Without a transformation, you may have efficiencies, but if you look at the Bureau of Labor Statistics report, right now, labor productivity in the United States, even with all the innovation that we've got going on, labor productivity growth in the United States has plummeted over 70% with the knowledge economy. Yeah. Okay. Yeah. Unless you're doing a transformation that is actually a creative process rather than a linear function, you actually have negative gains.
You know, this is really interesting because I've been reading a book on recently called I'm going to blank on the name. It's essentially it's on the what you're describing. The job market has essentially been compressed because of things like technology, but there's no place those people are really moving to. The economics around it aren't really transformative for the whole or the mass. They're transformative for a small group within the mass. Is that a fair way to describe what you're asking?
Can I say something?
Well, you can always say something.
Hey, David. Hey, everybody. I'm Ed. I'm the CEO of Verif-y. Just listening in. So
We got the
David,
whole team here today.
I'm sorry.
Oh yeah, we
We've
travel
got the
on
whole
a pack.
team here today.
I know we're all
But
learning.
we're
you know?
decentralized.
That is true. London, Oklahoma, Philly, we're all over.
So David, I think your question is very good. And I think it's been a lot of people that are involved in the blockchain space have been pondering about what's the killer app? What's the big change that blockchain brings with it? So I think the first thing that brings with it, unfortunately, is crypto. People have looked at transacting financial monetary values over different types of network for a very long time. And the fact that Bitcoin by itself is worth over $1 trillion right now is a significant part. So crypto is impossible without blockchain. So it's based on blockchain technology. So that's the biggest thing that people think about. When I say that we have a blockchain layer in our stack, they'll say, oh, crypto? No, that's nothing. It's a database layer. Blockchain is a database. It's a use of data in a certain way that can be equivocated to a database. So that's one aspect. Colleen mentioned decentralized, and I think the boat analogy is actually pretty cool. I didn't think about that before, but the ability to decentralize, to put data in different locations and have it validated by independent parties that are or are not validated, which is a whole different discussion, is unique by itself. And it's a continuous conversation that is happening by different people around the world. Is it really decentralized? Is it really anonymous? Is it really independent? So, but the ability to create data in different locations, and it's validated in all of those locations. So the one thing I wouldn't agree with Colleen on the boats is you have 20 boats, and if you take on one boat, you actually have nothing because the data still is the same on all the other 19. Right. So if you talk about data versus value, but the 20 boats exist, right? And all of this. So if you took one node in the example of blockchain, the other 19 nodes are independently working still. So the ability to do that is, again, a very significant tenet of blockchain technology. The fact that the data could be immutable, which means you cannot change it. Once it's done, it's set in the blockchain, it cannot be changed. And to the question before, if someone wants to change a transaction or if the transaction is wrong, you can't change it, it's done. You can create another one and say this one supersedes the one that was wrong, but you can't change the transaction unless you take down the whole blockchain, which is a whole different story, which I don't want to get into. So those are some of the major tenets of blockchain technology by itself. And those, as an aggregate or individually chosen, can create that exponential change that you talked about. Digital identity, which is where we focus, relies on some of the aspects and tenets of blockchain in order to create an immutable identity, an auditable trail of how the identity was created and who participated in the creation, what type of aspects happen, and what Colleen and David mentioned earlier, which is the privacy layer, the decentralized storage of the data actually allows the transition of data from the organization to the individual. That was a long-winded way to answer your question. I hope that gave you a little bit more.
I appreciate it. I don't want to hold the group hostage. So go ahead with other people's questions.
I just want to put, so we so David and Colleen just wanted, so we have just a few minutes left if you want to share any closing thoughts with us.
See, I still want to continue the conversation with David because that's a big thing for me. So now that I've dialed in, it's the
last few minutes. I think I feel like we've said a lot of almost concluding statements already in a way. So I'm kind of happy to field questions, and I'm always happy to talk offline. So I think that this is a really interesting and necessary conversation as in the tech world, right? And that obviously, as we were just talking about use cases, that technology then spans into many other industries in which it can be applicable. So I think, you know, this is just the start of a conversation, really, and we can just keep going. But you know, in the last 3 minutes, I'm happy to take another question or two, and yeah, go from there.
Yeah, there is a question in the chat asking if you're using OAuth for your identity verification. I'm hoping you know what that means. I do not.
Ed, you want to take that one?
Sure, there's a reason I'm here, right?
Exactly. This was the softball you've been dreaming about.
Exactly.
You too.
So regarding Hyperledger, OAuth, and Factum. So I'll start from the end. Hyperledger and Factum are their own instances of people that are trying to create identity. So Hyperledger, IBM, and others. Factum is Factum itself. And OAuth is a standard as well. We try to kind of stay away from all of these things right now. All of them, even the decentralized identifiers, the W3C, and a lot of others. And the reason is none of them are actually standards. None of them are standardized forms that we believe are proper. And we have a digital identity that's based on actually validated primary source data. As it becomes more prevalent, we'll decide if to include them under a blockchain infrastructure or not. Most organizations around the world, probably, which makes a lot of sense, are not able, willing, or even understand what blockchain technology is as it relates to integrating that with their infrastructures. So once you start throwing in a bunch of terms to them that they don't understand, the initial reaction we've gotten over the past 3 years that we've been in this market and selling products was, I don't want to hear about that. Can you solve my problem right now? So, and as Colleen said, a lot of organizations invested a lot of money and lost a lot of money trying to do this stuff. So there's more resistance today than there was in 2017 or 18. So our digital identity right now is only based, and there's all of that stuff in the back end, but it's only based on validating primary source or secondary source with appropriate data to solve identity needs of corporations, large corporations, organizations.
Well,
I'll just add to that we obviously are monitoring and, you know, very in the know when it comes to all of these other technologies, when it comes to specifically identity verification, because it's important for us to be aware of all the technology and the standards that are trying to be made. So this is something that is core to us, but we do, you know, kind of have our own way of looking at it.
all right. Well, thank you so much, Verif-y.